Hello everyone. Welcome to this video on learning mathematics through concepts and examples. Today we are going to work on mastery exercise 7 from your intro to statistics class. And the topic of this video is confidence interval. So let's get started with our first problem here. So here in first example, we are asked to find the critical value for a confidence interval of 90%, find critical value. So here we are talking about the 90% confidence level. And for that, we have to find the critical value. So first we need to understand the fundamental concept here. So I'm going to sketch a quick diagram to explain that. So for example, we have a normal distribution. Say, for example, this is the normal distribution. Okay, let's label this one. So this is my normal curve with the standard deviation, mean 0 and standard deviation 1. So I'm talking here about the standard normal distribution. Now we are looking for the critical value for 90% confidence level. So here in the middle, we have a 0, mean is 0. And along the x-axis here, we have the z values. So when we say 90% confidence level, we are talking about the middle 90% area. So if we want to show that, it should be something like this. So this is the middle 90% area. Let me say that. So this area here should be the 90% area. So that is 90% area or 0.90. And the values that separates this middle 90% area from the lower 5% area and upper 5% area, these values are critical values. So this is z sub c negative, and this is z sub c positive one. Positive. This is negative, this is positive. So this value is the critical value, and this one is the opposite of that. And we want to find that critical value. And what we know here is because we have 90% area in the middle, remaining 10% is distributed evenly on these two tails, on the left tail and on the right tail. So on the right tail, we have the 5% area. So this is 0.05. And also on the left tail, you have the 5% area or 0.05. So now, if we need to find this z critical, now let's say z critical is equal to, so we are calculating the value along the x-axis. So whenever we are calculating the value along the x-axis, we have to use inverse normal in our calculator. Inverse normal in our calculator. And then the first thing we put here is the area to the left of z critical. So here is our z critical. On the left, from here to here, we have a 90% area. On this side, we have 5% area. That means on the left, we have 95% area. In other words, you can also think like this. You can see here is our z critical. On the right, you have 5% area. That means on the left, you have the remaining 95% area. So for 95% area, we write 0.95. Then we put the mean for the standard normal distribution. Mean is 0 and standard deviation is 1, 0, 1. So what we are going to do is we are going to type this in our TI-84 calculator to get that value. Now in TI-84 calculator, we go to second, then vars, and then for inverse normal, it's number 3. So once you go there, it's asking for the area. So here we put area to the left of that z critical, which was 0.95 or 0.95, the 95% area. Mean is 0, standard deviation is 1. And if you paste this, you'll see what you have written on your paper, the same thing. And when you hit enter, you'll get the critical value of 1.6449. That is the z critical. So for the 90% confidence level, the critical value is 1.6449. So I just want to talk briefly about the confidence label and significance label here. Although we are done with the problem, I just want to explain a few things here. There are two things that we need to know. One is the confidence label. Confidence label. Confidence label is the value that is at the middle of this distribution here, which is generally denoted by C. Confidence label is denoted by C. Okay, confidence label denoted by C. There is the other one called the significance label. Significance label. Significance label is 1 minus the confidence label, and this value is denoted by alpha. So for example, in this example, this 0.90, that is your C. Okay, 0.90 is the confidence label C. Now, if you look at the significance label, so here we have the formula for significance label. Alpha is 1 minus C, so which is equal to 1 minus 0.90. C is 0.90, which is equal to 0.10. So that remaining percentage is your significance label. But here in this example, that significance label is divided on two tails. So the value on the two tail is half of alpha. So this one, 0.05, which is here, is alpha over 2. And also this one here on the left tail, that is alpha over 2, because alpha over 2 plus alpha over 2 is alpha, which is 10% or 0.10. So that is the relationship between the confidence label and significance label. So if the confidence label is C, significance label is alpha, which is denoted by alpha and is calculated using 1 minus C. So you can say the value of C and alpha, if you add them together, that is equal to 1. The confidence label plus significance label is equal to 1. So that is the relation that we need to know. Now, one more time, in this problem, we found the critical value for 90% confidence label. So for 90% confidence label, the critical value is 1.6449. Now for next two problems, we are going to use this critical value for the 90% confidence label. So let's move on to example 2. So here is our second example. So here in this example, if n equal to 290, so that should be the sample size. P hat, the proportion, is 0.84. We are asked to find the margin of error for 90% confidence label and give your answer to 3 decimal places. So what we know is when we are talking about the proportion here and talking about margin of error, we have the formula for margin of error. Margin of error is equal to Z critical multiplied to the square root of P hat Q hat over N. This is the formula. So here we are talking about 90% confidence label. As you can see there, the value of the confidence label C is equal to 0.90. But what we know is from the first example, at C is equal to 0.90, the critical value is 1.6449. So if you want to know how to calculate this one, refer back to example 1, which is calculated there. So we have this Z critical. Okay, we have the Z critical. Also, P hat is given. Also, P hat is given. P hat is 0.84. So now what we need is Q hat. But what we know is P hat plus Q hat is 1. So Q hat will be 1 minus P hat. 1 minus 0.84, which will be equal to 0.16. That means the proportion of the population here is 84%. So the complement of that will be 16%. So once we have this Z critical, once we know the P hat and Q hat and also this N, which is given here in the problem as 290, we can plug in here to find the margin of error. So this is equal to Z critical is 1.6449 multiplied to square root of P hat is 0.84 times Q hat is 0.16, and then the value of N is 290. So now to find the margin of error, all we need to do is type this in our calculator and simplify. So if you do that, you should get 0.035. So the margin of error for this problem is 0.035. Example 3. In a recent poll, 240 people were asked if they like dogs. So here the value of N is 240. Okay, value of N is 240. And 35 said they did. So the proportion of the people who said they like dog, P hat, is 0.35. Now what we need to do is we have to find the margin of error for this poll at 90% confidence level. So when we say at 90% confidence level, the value of C is 0.90. Now here we are looking for the margin of error. So we know the formula for margin of error. When you have the proportion, the margin of error is Z critical multiplied to square root of P hat times Q hat divided by N. And if we look carefully here, first thing we need is Z critical. And what we know from example 1 is, here we are talking about the 90% confidence level. So at C equal to 0.90 or at 90% confidence level, Z critical is 1.6449. This is from example 1. Okay, if you need to review that, you can go back to example 1 and watch it again. So we have Z critical. Also, we have P hat here. P hat is 0.35. Next thing we need is Q hat. Q hat is 1 minus P hat. So that is equal to 1 minus P hat is 35% or 0.35. That should be equal to 0.65. So now we have a Z critical, we have P hat, which is here. We have Q hat, which is here. N is given 240. So all we need to do is plug in the value and find that margin of error. So let's plug in Z critical 1.6449 multiplied to the square root of P hat is 0.35 times Q hat is 0.65 divided by N is 240. So now we need to simplify this using calculator. So upon simplification, you should get 0.051. Make sure you check it and verify that it must be 0.051. So the margin of error here is 0.051. Example 4, if N equal to 460, so they have given the value of N is 460, P hat is 0.15. We are asked to construct the 99% confidence interval. So we are actually constructing the confidence interval here, and we are asked to write the answer up to 3 decimal places. So here the value of C is 99%, as you can see. Value of C is 0.99. So now, first thing first, what you have to do is, for the 99% confidence interval, we need to find the Z critical. In the previous 3 example, we used we had the 90% confidence interval, and we calculated that critical value in example 1, and we did use that for example 2 and 3. But here we are talking about 99% confidence interval, so we need to actually calculate the critical value. So first, we are going to sketch the diagram. So let's say that is our normal distribution. standard normal distribution with mean 0 and standard deviation 1. Z values along the x-axis. In the middle, we have 0. Now we want 90% area in the middle. I mean 99% area in the middle, because we are looking for 99% confidence level. So the area that is in the middle, this area is the 99% area. This is 0.99. Now the remaining 1% area is divided on two tails. So if we have 99% there, so it's like 1 minus 0.99, that will be 0.01. So this value is your C. Okay, C is equal to 0.99. So alpha is 1 minus 0.99, which is the area on the tail, that is 0.01. But remember that 0.01 is divided on two tails, on the left and also on the right. So if we divide that by 2, the value of alpha over 2, okay, value of alpha over 2 will be 0.01 divided by 2. That is equal to 0.005. So this area here is 0.005. Similarly, this one is 0.005. In other words, you have 99% area in the middle. So the remaining 1% is divided into two parts. So 0.5% area on the right tail and 0.5% area on the left tail. Now, once we know this, we are looking for the Z critical, that is the value here. Okay, this is Z critical. And this one is the opposite of that. So it will be the negative of that. So now, in order to find that Z critical is inverse normal. So we are calculating this Z critical. We need the area on the left. Area on the right is 0.5%. So area on the left will be 99.5% or 0.995. In other words, to find the area on the left of Z critical, you add this area in the black, which is 0.99, plus the area on the red, which is 0.005. That will give you 0.995. And then the mean is 0 and standard deviation is 1. Mean is 0 and standard deviation is 1. Now, if you use that inverse normal in your calculator, you should get 2.5758. So make sure you use inverse normal and then check this value. If you need to know how to use calculator for inverse normal, you can go back and watch example 1, because I showed you how to use inverse normal and then find the value. So if you need reference on how to use calculator, go back to example 1 and watch that video again. Okay, once we have the critical value, we are looking for the confidence interval. So let's briefly talk about that. So when we talk about the confidence interval, so in the middle, we have the point estimate. Okay, in the middle, we have the point estimate, that is P hat, which is already there in the problem. P hat is 0.15. We already have that 0.15. Now we are constructing the interval. So the lower boundary will be P hat minus the margin of error, and the upper boundary will be P hat plus the margin of error. So clearly you can see that we already have this value. We need the lower boundary and upper boundary for the confidence interval. So for that, we need to find the margin of error. For the left boundary, we need to subtract that margin of error from P hat. And for the right boundary, we have to add that margin of error from P hat to P hat. So now let's find that margin of error. Now margin of error is given by the formula Z critical multiplied to P hat times Q hat divided by N. So we can plug in the formula values now. Z critical is this one, which is 2.5758. Okay, that's your Z critical. Multiplied to the square root of P hat is 0.15 or 15%. That means Q hat will be Q hat will be 1 minus P hat, 1 minus 0.15, that is equal to 0.85 times 0.85 divided by the value of N is 460 here. 460. So this implies your margin of error is equal to, now we need to simplify this using calculator, and if we simplify we get 0.043. 043. I'm writing up to 3 decimal places because that's what is asked in the question. So margin of error is 0.043. But we are looking for the confidence interval. That is, we need to find the lower boundary and upper boundary for the interval. So the lower boundary is P hat minus margin of error, which is 0.15 minus 0.043. And if you do that, it is equal to 0.17. P hat is 0.15 and you are subtracting that value. So if we subtract that, it will be 0.107. Okay, 0.107. That is the lower boundary. So here it is like 150. Now when you subtract, it will be 107. Now the upper boundary will be P hat plus the margin of error. P hat is 0.15 plus the margin of error is 0.043. And this value will be 0.193. So make sure you use your calculator and check these two end values. So the lower end that we are getting is 0.107. So this is here 0.107. And the upper boundary for the interval is 0.193. Meaning of that is, we can say that the true population proportion P, okay, true population proportion P lies between 0.107 and 0.193. And we can say that with 99% confidence. So we can write, hence the confidence interval is 0.107. So P is between 0.107 and 0.193. So this is the confidence interval. Your P is between, as I have shown here, P is between 0.107 and 0.193. Example 5. Out of 200 people sampled, that means that is your sample size, N is 200. Out of 200 people sampled, 72 had kids. X equal to 72. 72 people had kids. Based on this, we are asked to construct 90% confidence interval. So here, C is equal to 90%. And what we know from example 1 is, at C equal to 90%, okay, at 90% confidence level, the critical value is 1.6449. Okay, critical value at 90% confidence level is 1.6449. If you need to know how to calculate this one, you can always go back to example 1 and watch that video. Okay, so we have the Z critical. Now the question here is, we are asked to construct that 90% confidence interval for the true population proportion of the people with the kids, and we are asked to write the answer to 3 decimal places. So first, let's find P hat. So here P hat is X out of 200, okay, or X out of N, you can say, X out of the total, which is same as 72 out of 200. That is 36% or 0.36. So if that is the case, then you know what is Q hat. Q hat is 1 minus P hat, so 1 minus 0.36, which will be equal to 64% or 0.64. So we have P hat and Q hat. We are looking for the 90% confidence interval. So in confidence interval, what we have is right in the middle, we have the point estimate, that is a P hat. And in this case, our point estimate P hat is 0.36. And for the interval, we have to find the lower boundary and the upper boundary. Lower boundary is P hat minus the margin of error, and upper boundary is P hat plus the margin of error. So what we need is, we already have P hat here, so we need to find the margin of error so that we can subtract that or add that to get the lower and upper boundary. So now let's find that margin of error. Now, the margin of error is given by the formula Z critical multiplied to square root of P hat Q hat divided by N. Z critical 1.6449. As I mentioned here, this is from example 1. Multiplied to the square root of P hat is 0.36, Q hat is 0.64, divided by N is 200 people. Now, if you simplify this using calculator, you should get 0.056. We are asked to write up to 3 decimal places, so 0.056. So make sure you type this in your calculator and verify that this is true. Okay, once we have the point estimate in the middle and we know the margin of error, we can easily find the lower boundary and upper boundary for the interval. So the lower boundary, which is P hat minus margin of error, is equal to 0.36 minus 0.056. And if you subtract that, you should get 0.304. Make sure you check it. Now the upper boundary, P hat plus margin of error, let's say P hat plus margin of error, which is 0.36 plus 0.056, and that is equal to 0.416. So the lower boundary here is 0.304. That's what we got here, 0.304. And upper boundary is 0.416. 0.416. That means we can say that the true population proportion P, okay, true population proportion P lies between these two values. And we can say that with 90% confidence. So we can say, hence the confidence interval, hence the 90% confidence interval is that P is between these two values. So we can write like this, 0.304 is less than P is less than 0.416, or in other words, P is between these two values. So this is the confidence interval, or we can say that the true population proportion is between these two values, between 30.4% and 41.6%. So with 90% confidence, we can say that 30.4 to 41.6% of the people have kids. Okay, time for example 6. A political candidate has asked you to conduct a poll to determine what percent of people support her. If the candidate only wants 4% margin of error at 95% confidence level, what is the sample size needed? Give your answer in whole people or whole number there. So here we are talking about the candidate who asks you to determine what percent of people support her. So if the political candidate, or you can say if the people are in favor of a political candidate, then the minimum proportion should be, minimum proportion of the people who support should be at least 51%. So P hat must be 0.51, because if it is 50%, so When we have 50%, then 50% people will support, 50% will not. So in order to get the majority of people supporting the candidate, it should be a minimum of 51%. So P hat is 51. So meaning of that is a Q hat will be 1 minus P hat, which is equal to 0.49. That is 49% not in favor. That is the minimum requirement. If the candidate wants 4% margin of error, so here in the problem, they have given margin of error is 4% or 0.04. And we have to find the sample size needed for that survey at 95% confidence level. So C is equal to 0.95. Now, if you remember the formula for the sample size, this is what we have. We know the sample size N is equal to P hat multiplied to Q hat multiplied to Z critical over the margin of error squared. So if you look here, what we need to determine that sample size is we need P hat, which is 0.51. We need Q hat, which is 0.49. Margin of error 0.04. But Z critical, we don't have Z critical. So we need to first find the Z critical at this 95% confidence level. So for that, what we do is first we are going to draw that normal distribution. Let's first sketch the graph for the normal distribution like that. So suppose this is the standard normal distribution with the mean 0 and standard deviation 1. So meaning we have 0 here in the middle. Along the x-axis, we have the Z values. We are looking for the critical values at 95% confidence level. That means we know the middle 95% area. So this area in the middle is the 95% area. So this is C equal to 0.95. Now the remaining area, which is 5%, is divided on 2 tails. So that means on each tail, we have 0.5% or 2.5%, 0.025. Here, and also here we have 0.025. So this value here is the critical value, Z sub C. That is Z sub C. So this value on the other side is the opposite of that, negative Z sub C. Now, in order to find the value along the x-axis, like this one, Z sub C, we use inverse normal in our TI-84 calculator. So inverse normal, and then we put the area to the left of Z sub C. You can see area on the right is 2.5%. That means remaining 97.5% is on the left. So that will be 0.975 is the area on the left. Or in other words, if you add this red area and this area here, 0.95 plus 0.025, that is 0.975. Mean is 0 and standard deviation is 1. Now in your TI-84 calculator, if you go to second bars and number 3, you'll see inverse normal and you'll plug in these values and enter, and you should get 1.96. So the critical value that we are looking for is 1.96. So make sure you type this in your calculator and check that. Now, once we have this value, we are going to plug in to the formula. So let's plug in here. P hat 0.51, Q hat 0.49, Z sub C, we got 1.96 over margin of error given in the problem, 0.04. We plug in there, 0.04, and we square it. Now, if you simplify this and round it to a whole number, because we are looking for the number of people, so it must be a whole number, you should get approximately 601. Make sure you type this in your calculator and verify that value. So it must be 601. So you must survey at least 601 people, okay, to check whether the candidates get the support from the people or not. And that will be within 4% margin of error at 95% confidence level. Okay, now let's work on example 7. You intend to estimate a population proportion with a confidence interval. The data suggested that the normal distribution is reasonable approximation for the binomial distribution in this case. Find the critical value that corresponds to 99.5% and give your answer to 3 decimal places. So here, although we have so much words there, we are looking for only one thing. That is, we are looking for the critical value, okay, that corresponds to 99.5% confidence level. So because we are looking for the critical value, first we are going to draw the normal distribution. So that's where we are going to begin. Suppose that is my normal distribution. Say that is my normal distribution with mean 0 and standard deviation 1, z values along the x-axis, mean 0 in the middle. So we are looking for the critical value that corresponds to the confidence interval of 99.5%. So we have 99.5% area in the middle. Okay, 99.5% area is in the middle. That is the 99.5% area. So this is your C. C equal to 0.995, 99.5% area. Now the remaining area is divided in 2 tails. Remaining area is divided in 2 tails. So if this is the confidence level, the remaining is called the significance level, which is divided on 2 tails. So this value is alpha over 2. Similarly, this value is also alpha over 2. Now we need to find this value. What we know is if we add C and alpha, it is equal to 1. So alpha will be equal to 1 minus C. Our alpha is equal to 1 minus your C is 0.995. So alpha will be equal to, so now if you subtract that, you can see it will be 0.5% or 0.005. That's your alpha. But what we need is we need to divide that into 2 parts, on the left tail and also on the right tail. So this implies your alpha over 2. When you divide that, it will be 0.0025. So this area on the right tail is 0.0025. This area on the left is also the same, 0.0025. So that is the first thing we want to do. Okay, we need to create this diagram properly. And once we have that, we need to find this Z critical. Okay, we need to find that value, Z critical, Z sub C. And the value over here is the opposite of that. That will be negative Z sub C. Now what we know is, in order to find the value along the x-axis, like this Z critical, let me write here. We use inverse normal in our calculator. Inverse normal. Okay, inverse normal. Now, first we need the area to the left. So area to the left of this one, area to the left of Z critical here is this value 0.0995 plus 0.0025. So if you add these two, you'll get the total area on the left, this value plus this one. So if you add those two values, it will be 0.9975. Okay, or in other words, you have 99.75% area on the left and you have only 0.0025, or if you try to change it to percentage, that will be 0.25% area on the right. Okay, so mean is 0, standard deviation is 1. Now, if we type this in our calculator, in TI-84 calculator, in order to get to inverse normal, you have to press second, then vars, and then number 3. And once you input these values and enter, you should get the value of Z critical, which will be 2.807. Okay, 2.807 is the critical value for 99.5% confidence level. Okay, that is your seventh example. We have a similar type of question in eighth example. Let's first read through. You intend to estimate the population proportion with confidence interval. The data suggests that the normal distribution is a reasonable approximation for the binomial distribution in this case. What is an uncommon confidence interval? So here we are looking for the confidence interval. Find the critical value that corresponds to that confidence. Okay, in fact, well, it's an uncommon confidence interval when you want to, find the confidence interval like 89.8%, but we are asked to find the critical value that corresponds to that confidence interval. Okay. Anyways, so to find the critical value, okay, to find the critical value, here we are asked to find the critical value that corresponds to that. First, we need to draw the normal distribution. That's where we begin. So suppose that is my normal distribution. So standard normal distribution with mean 0 and standard deviation 1, z values along the x-axis, 0 in the middle. And 89.8% is in the middle because that is the confidence interval that we are looking for. So we have this area in the middle, and this area is your C. Okay, C is equal to 0.898. That is the area in the middle. Now we need to find the area on the tail. Area on the tail is the remaining area. That is, if you subtract from 1, so 1 minus 0.898 and divide that result by 2, you will get 0.051. So this area is 0.051. Similarly, this one will also be 0.051. And the values on the x-axis over here, that is Z critical. And the other one, which goes here, is the negative of that. So that is negative Z critical. So now we know how to find Z critical, the value along the x-axis. So if we want to find the value along the x-axis, that is inverse normal, area to the left. You can see area on the right is 0.51 or 5.10%. So the remaining area will be 94.9%. So if you add this value here, this area, and this area, 0.0898 plus 0.051, it will be 0.949. That is the area to the left, because in inverse normal, we put area to the left of Z critical. Mean is 0 and standard deviation is 1. So that will be equal to, when we simplify this, we'll get 1.635. So Z critical in this case is 1.635. So the critical value that corresponds to 89.8% confidence level is 1.635. Okay, that's example 8. Let's move on to example 9. Here is our example 9. Express the confidence interval in the form of p hat plus or minus margin of error. Okay, if you think of the general confidence interval, it will be like this. Let me draw a quick diagram here using the number line. Okay, so in the confidence interval, right in the middle, we have the point estimate, and you can clearly see the point estimate in this case is p hat. The left boundary is p hat minus the margin of error, and the right boundary is p hat plus the margin of error. Okay, so interval is given in this form. They have given the end point. End point here is 83%, and the end point on the other side is 93.2%. 93.2%. Now we need to find the value of p hat and margin of error. So let's first find this p hat. So here your p hat is equal to, okay, if you look at it carefully, p hat is the value in the middle. So to find the value in the middle, we add these two numbers and divide by 2. So it will be 83 plus 93.2. Once you get the result, divide that by 2. So that will be equal to, if you add these two values, okay, if you add those two values, it will be 176.2, and you're dividing that by 2, which is equal to 88.1. So the value that goes here in the middle is 88.1%. Okay, so that is the value of this p hat. Now we need the margin of error. So margin of error is equal to, because we need p hat plus or minus margin of error. Now margin of error, if you look at the diagram, is either this distance, okay, or it is this distance. Both are equal. So this is margin of error or this is margin of error. So in order to find this distance between these 2 points, you can subtract 88.1 from 93.2, or you can subtract 83 from 88.1. So either way, it works. Okay, now, so here we have 88.1. If you subtract 83, you get the value. Okay, or 93.2 minus 88.1, you get that value. So let's do 93.2. 93.2 minus 88.1. And if you subtract, that is equal to 5.1%. 5.1%. So our final answer, which we are asked to write in this form, will be our p hat. You can see our p hat is 88.1. So it will be 88.1. Then plus or minus the margin of error, we got 5.1. So that's another way of writing the confidence interval. So this is in the interval form. This we have written in the form of the point estimate plus or minus the margin of error. So that is our final answer, 88 plus or minus 5.1. Okay. That is the end of example 9. Time for example 10. Let's read what is given. A 2011 Gallup survey based on telephone and face-to-face interviews with 4,220 adults in China, aged 15 and older, suggests that 30% smoke regularly or occasionally. The following is also noted. One can say with 95% confidence that the maximum margin of sampling error is 2.2%. So here when we say 2.2% as the margin of error, that is, you can go 2.2% down or 2.2% up from 30%. So what I mean by that is here you have a 30%, and then if you want to go down 2.2%, that is 30 minus 2.2, okay, which will be equal to 27.8. Okay, that will be 27.8. And if you go 2.2% up, it will be 32.2. That means with 95% confidence, we can say that the smoker who smoke regularly has this range here. Okay, which of the following is a true based on the result of this survey? So you can clearly see we have these two key numbers, 27.8 and 32.2, which is here in the fourth one. So we are 95% confident that 27.8% to 32.2% of all Chinese adults smoke. So the correct option is the fourth one. So you can select the fourth one there. So that is example 10, which was quite easy. We just have to look for the range and we can easily figure out the correct option out of these given options. Okay, now example 11. So let's find out what is here in example 11. Okay, in a sample of 250 adults, 155 had children. So you can see the total number here is n. Out of this n, we have 155 with the children. That means the proportion of the population with the children, or proportion of the sample with children, I should say, is 155 out of 250, which is equal to 0.62. So this implies if you want to find q hat, it is 1 minus p hat, 1 minus 0.62, which is equal to 0.38. Now we are asked to construct 90% confidence interval for the true proportion of the adult with children. So if we want to construct the confidence interval, what we know is in the middle, we have the point estimate. In this case, it is p hat, which is 0.62. Now to this, we have to subtract the margin of error to get the lower boundary. And then we have to add the margin of error to get the upper boundary. So the key here is to find that margin of error. So now let's work on finding the margin of error. The formula to compute margin of error when the proportion is given is z sub c multiplied to the square root of p hat times q hat over n. That's our formula. Now, for the 90% confidence interval, which is mentioned here, okay, 90% confidence interval, from example 1, we know that the z sub c is 1.6449. So we are going to use that value, 1.6449, multiplied to square root of p hat is 0.62 times q hat is 0.38 divided by n is the sample size, which is 250. And now if we simplify this, we'll get 0.051. So that is the margin of error. Now, once we know the margin of error, we can easily find this lower boundary, and also we can find the upper boundary. So let's do that. Okay, lower boundary. That is p hat minus margin of error, which is 0.62 minus 0.051. And if we subtract, we get 0.569. So that is the lower boundary, 0.569. That is the lower boundary. Now we need the upper boundary, which is p hat plus margin of error. P hat plus margin of error. P hat is 0.62 plus the margin of error is 0.051. And if we add these two numbers, it will be 0.671. So the upper boundary is 0.671. So our confidence interval, the 95% confidence interval, is the true proportion P lies between these two values. So we can say 0.569 is less than P is less than 0.671. So that is the confidence interval. In other words, P lies between these two values. So we can say that with 90% confidence. That is example 11. Okay, example 12. You measure 32 randomly selected textbooks weights and find they have the mean weight of 33 ounces. Assume that the population standard deviation is 7.4 ounces. So now here we know the mean of these randomly selected 32 of them, right? So your sample size is 32 here. Randomly selected textbook, okay? So n equal to 32. You found the mean to be 33 ounces, and then the standard deviation is 7.4 ounces. So that is the standard deviation given. Based on this, we have to construct the 99% confidence interval for the true mean textbook weight. And we have to give our answer as a decimal. Okay, let's work on this now. Before we begin, one thing to note here, they have given the population standard deviation. So this standard deviation is the population standard deviation sigma. So still the Z value works fine here. Okay. So first of all, when we try to construct the confidence interval, what goes in the middle is the point estimate. In this case, it is the X bar or the mean, which is 33. So 33 goes in the middle. And then we find the lower boundary, which is mean minus the margin of error. Upper boundary is mean plus the margin of error. So we have this middle value. What we need is the margin of error. We know the formula for margin of error. We know margin of error is Z critical multiplied to sigma over the square root of n. But for the 99% confidence interval, which is given in the problem, okay, this one, for 99% confidence interval, Z sub C is equal to 2.5758. This is the value from example 4. If you need to know how to find this Z critical for 99% confidence interval, you can go back and watch example 4. But for here, we are using that value and we are going to plug in here. It's 2.5758 multiplied to population standard deviation 7.4 divided by the square root of the sample size, which is the square root of 32. And if we simplify this using calculator, it will be 3.37. So margin of error is 3.37. So now what we need to do is we need to find the lower boundary and upper boundary there. So let's work on that part. Now the lower boundary is the mean minus margin of error, which is 33 is the mean, minus the margin of error is 3.37. If we subtract this, we get 29.63. That is a lower boundary that will go here, 29.63. Now, in order to find this upper boundary, we have to find X bar plus the margin of error. Mean plus sample mean plus the margin of error, which is 33 plus 3.37, which is equal to 36.37. So this value is 36.37. So we can say that the true population mean lies between these two values. And we can say that with 99% confidence. So finally, we can write our confidence interval. Your mean is between 29.63 and 36.37. So that's our confidence interval. Mean lies between these two values. Example 13, a student was asked to find the 95% confidence interval for the ways with using the data from a random sample of size 29. Which of the following is the correct interpretation of this interval? You can see here the interval is 10.8 is less than mean is less than 31.8. That means you have the value in the middle as the point estimate here. Okay, we don't know what it is, but we know that the true mean lies between these two values. So if you look at it carefully, I think the second one makes more sense. I'm going to tell you why. Because I already scanned all of them. That's why. With 95% confidence, the mean width of randomly selected ways will be between 10.8 and 31.8, because we can say that the true mean lies between these two values. And we can say that with 95% confidence. That's why the second option is the correct option. Example 14 again. In example 14, let's see what is given. The age when the smokers first start from the previous study is normally distributed with a mean of 13 years old and the population standard deviation 1.5. Okay, we know the mean and the population standard deviation. Okay, a survey of a smoker of this generation was done to estimate if the mean age has changed. The sample of 35 smokers, so you can see the sample size, sample of 35 smokers, okay, 35 smokers found that their mean age was 14.4 years. So mean age of the sample is 14.4. Also, the population standard deviation is given here, which is 1.5 years. We have to find the 90% confidence interval for the mean. So we are looking for the confidence interval, but that should be the 90% confidence interval. Okay, so for the confidence interval, you can think of a number line, and then you have the point estimate in the middle. In this case, it is the mean, which is 14.4. It's already given. Now we need to find the lower boundary, which is mean minus the margin of error, and the upper boundary, which is the mean plus the margin of error, so that we can say that the true mean lies between these two values with 90% confidence. So since we have this X bar already, what we need to find is the margin of error. So let's work on that. So here, what we know is the margin of error is equal to z sub c times sigma over the square root of n. But what we know is for the 90% confidence interval, okay, for the 90% confidence interval, we know z critical, z sub c is 1.6449. We know this from example 1. So if you need to review how we get this value, you can go back and watch example 1. But here we are just going to use that value. So that is 1.6449 times 1.5 is the population standard deviation, divided by the square root of the sample size, that is the square root of 35, which will be 0.4171. Okay, so once we have the margin of error, now what you can do is we can subtract that margin of error from point estimate to get the left boundary. So let's do that. Now our left boundary is the mean minus the margin of error, which is equal to 14.4 minus 0.4171. That is equal to 13.983. Okay, 13.983. That is the left boundary or lower boundary. And we use 3 decimal places because the question is asking us to write up to 3 decimal places. Now we find this upper boundary, which is mean plus the margin of error. Mean plus the margin of error. 14.4 plus 0.4171, which will be equal to, if you add this, it will be 14.817. 14.817. So with the 90% confidence, we can say that the true mean lies between these two values. So we can write the confidence interval. So the confidence interval will be mean is between 13.983 and 14.817. So that is the confidence interval that we are looking for. Example 15 now. Let's see what we have in example 15. So this one looks a little different, but not very difficult. Okay. You work for a company that produces electronics with integrated circuit or IC circuit. One of your products is called a shift register. This product is designed to automatically shut down if its operating temperature exceeds 175 degrees Celsius. The manufacturing process has been designed to have the standard deviation, the population standard deviation of 0.4 degrees Celsius. So that is the population standard deviation. You test a random sample of 16 shift register. That's your sample size, n equal to 16. And you record the following shutdown temperature. So we have the 16 data here, 175.27, 174.42, 175.04, and so on. Okay. What we are asked to do is we are asked to construct a 98% confidence interval for the overall mean shutdown temperature. So here we have the sample data. What we can do is we can enter this in our TI-84 calculator and then find the sample mean. Okay, we can find the sample mean and the sample standard deviation. So I think the important thing here is the sample mean first. So we are going to find that. So sample mean, if you enter this data in your calculator and calculate the mean, that should be 174.9244. That is the sample mean, or that will be the point estimate. So meaning of that is, if we are constructing the confidence interval, the value that goes in the middle, or your confidence, the point estimate will be 174.9244. That's what we know. Now, in the first part, we are asked to find the critical value and sigma sub x bar. So for first part, we are looking for the critical value, z sub c, okay, z sub c for 98% confidence level. So to find z sub c, the value along the x-axis, we use inverse normal. Area to the left, you can see the middle area is 98%. So remaining 2% is divided on two parts or two tail. That means on the left, you have the 99% area or 0.99. Mean is 0 and standard deviation is 1. And if you type that in your TI-84 calculator, you should get 2.3263. If you need to review how we do this one or how we find the Z critical for any confidence level, here it is 98%. Okay, you can watch example 1 or example 4. In example 1 and example 4, I showed how to calculate the critical values. We are working on part A now. So we got that Z sub C. The next one is we have to find sigma sub x bar. Now, sigma sub x bar, or the standard deviation for the sampling distribution of sample mean, or that is also called the standard error for the mean, is equal to sigma over square root of n, which is equal to 0.4 over square root of 16, or 0.1. So that is the first part. We got the Z critical, and also we got this value there. Now for part B, let's see part B. So for part B, we are asked to find the confidence interval. In order to find the confidence interval, we need to find the margin of error first, because what we do is in the confidence interval, here we find the lower boundary, which is mean minus the margin of error, and the upper boundary, which is mean plus the margin of error. But what we know is the margin of error is equal to Z critical multiplied to sigma sub x bar. And we have both of these values in part A. This is same as Z sub C multiplied by this value is same as sigma over square root of n. We can also write like this, Z critical times the standard error of the mean. So we can multiply these two. It is 2.3263 multiplied to 0.1, which is equal to 0.2326. When you round to 4 decimal places, that's the margin of error. Now you can subtract the margin of error to get the lower boundary. So mean minus margin of error is equal to 174.9244 minus 0.2326. And if we subtract this, we get 174.6918. Okay, 174.6918. That is the lower boundary. Now for upper boundary, we have to add mean and margin of error. Okay, mean plus the margin of error is 174.9244 plus 0.2326, which is equal to 175.1570. So that is 175.1570. So we can say that the confidence interval is between these two values, or we can say with the 98% confidence, we can say that the true mean lies between those two values. Hence, we can write our confidence interval. So let's write this down. Confidence interval, your mean is between 174.6918 and 175.1570. Example 16, you are interested in estimating the mean age of the citizens living in your community. In order to do this, you plan on constructing a confidence interval. However, you are not sure how many citizens should be included in the sample. If you want your sample estimate to be within 3 years of the actual mean with the confidence interval 96%, how many citizens should be included in your sample? Assume that the standard deviation of all ages of all citizens in the community is 25 years. So when you look at it, you can see there are a few important things given. The first one is the margin of error, which is 3 years. So because it says the estimate is within 3 years, that is the margin of error. Confidence interval is 96%. So C is equal to 0.96. So your alpha will be 4% or 0.04. How many citizens would be included in the sample? So we have to find N, and the population is standard deviation sigma is given. Now, when we have the information like this, and when we want to find the sample size, what we know is this. We know the sample size N is equal to Z critical multiplied to sigma over the margin of error squared. So we have the sigma, we have the margin of error, but we don't have the Z critical at 96%. Now, if you want to find the Z critical at 96%, that is equal to inverse normal. Area to the left of Z critical will be 96 plus alpha over 2, or half of 4%, that is 2%. So 96 plus 2% will be 98%, area will be on the left. So 0.98, mean 0, standard deviation 1. And if you perform that calculation in your calculator, it will be 2.0537. But if you don't follow this one, I have shown how to calculate the Z critical at certain confidence level in example 1 and 4. So you can go back and watch those two examples. So here, Z critical for 96% confidence level will be 2.0537. Now we plug in the value here. 2.0537 times the standard deviation is 25, margin of error is 3, and then we squared it. And we round it to the upper number because it is N, the population size. So if we simplify this one, it should be 293. So the sample size required is 293. Now we have 2 more examples remaining. And you can see that up to here, we have Z critical or the standard normal distribution. But in the next 2 examples, you'll see T distribution. Example 17. In a survey, 28 people were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped with the mean of 42 and standard deviation 17. Construct a confidence interval at 95% confidence level and give your answer to 1 decimal place. So here, let's see what is given. We have the sample size, 28. 28 people were asked how much they spent on their child's birthday gift. And we found that the result were roughly bell-shaped with the mean of 42. So that is the mean of the sample. Mean of the sample is 42. And the standard deviation of that sample is 17. So here you can see that the standard deviation of the sample is given, but the standard deviation of the population is not given. That means the distribution that we have here is the t distribution. Let me write that sentence first. Since the population standard deviation sigma is unknown, okay, the distribution is t distribution. Distribution is t distribution. So here we are looking for 95% confidence level. So C is equal to 0.95. But since this is the t distribution, we need to find the t critical. So let's first do that calculation. So we'll draw the t distribution here, which is roughly bell-shaped again. Okay, so in case of t distribution, we have t values along the x-axis, and we need the degrees of freedom, which is the sample size minus 1. So here is 28. So 28 minus 1 will be 27. 27 is the degrees of freedom. And we are looking for 95% confidence interval. That means the middle area that we'll be looking for is the 95% area. So this is 0.95 or 95%. And then we have remaining 5% divided on the two tails. So here on the right tail and here on the left tail, we have 5% divided into two parts. So that is 2.5% on each tail, 0.025. This side also 0.025. And the value here is the t critical. So this value is t critical. Now, in order to find t critical, we go to inverse in our calculator, we go to second vars and we choose inverse t. So we choose inverse t because this is a t distribution, and then we write the area to the left. Area on the right is 2.5%. So area on the left is 97.5%. 0.975. We don't need mean and standard deviation. We just need this degrees of freedom, which is 27. And if we do that, the value will be 2.0518. So that is the t critical. This will help us to find that margin of error for the confidence interval. So now let's find that margin of error. Now, margin of error is t critical multiplied by s over the square root of n. Sample standard deviation divided by square root of n. T critical is this value, which is 2.0518 times the sample standard deviation is 17 divided by square root of 28. Since we are asked to write answer to 1 decimal place, we simplify this and write up to 1 decimal place, which will be 6.6. So the the confidence interval, the 95% confidence interval will be, we have the point estimate and then we add or subtract the margin of error. That is one way of writing the confidence interval. So let me write like that. So here the point estimate x bar is 42. Then we have plus or minus. The confidence of the margin of error is 6.6. So that is our confidence interval. Okay, 42 plus or minus 6.6 is the 95% confidence interval. Karan wants to advertise how many chocolate chips are in each big chip cookie at her bakery. She randomly selects 54 cookies and finds that the number of chocolate chip per cookie in a sample has a mean of 11.5 and a standard deviation of 21. What is 95% confidence interval for the number of chocolate chips per cookie for big chip cookies? And we have to enter the answer to 1 decimal place. Okay, so here also, like in the previous example, we are talking about the 95% confidence interval, something to note there. Okay, but here the sample size is 54, n equal to 54. Sample has a mean of 11.5, and the sample has the standard deviation of 2.1. That is the sample standard deviation. So because we have the sample standard deviation, this is the t distribution. So again, we can write, since population standard deviation sigma is unknown, the distribution is t distribution. That is something to note. Also, what we know from previous example is also t critical for 95% confidence interval is t sub c, that is equal to 2.0057. If you need to know how to calculate this value, go back to example 17 and watch that video again. I've explained the procedure here, how we can find that t critical for 95% confidence level. Now, once we have this, thinking about that confidence interval, you know that what goes in the middle is the point estimate. In this case, it is a mean, which is 11.5. And then we have to find the lower boundary, which is mean minus margin of error. And then the upper boundary, which is mean plus the margin of error. Now, in order to get those lower and upper boundary, we need margin of error. So let's find margin of error. Now, margin of error is given by the formula t critical multiplied to standard deviation of the sample divided by square root of n. T critical is here 2.0057 multiplied to sample standard deviation is 2.1 divided by the square root of sample size, which is 54. And if you simplify this, you will get 0.6. I'm rounding to 1 decimal place because we want, I'm rounding to 1 decimal place because we want to give the final answer to 1 decimal place only. Okay, once we get this margin of error, we can find the lower and upper boundary. So let's do that. So you can see your lower boundary is mean minus the margin of error. So mean minus the margin of error is equal to 11.5 minus the margin of error that we are looking for is 0.6. Okay, so you can perform the actual calculation here to get 10.9. And then mean plus margin of error will be 11.5 plus 0.6. That will be equal to 12.1. So we got the lower boundary that goes here, which is 10.9. And the upper boundary that goes here is 12.1. So we can say with 95% confidence that the true mean lies between those two values. Okay, so hence we can say the confidence interval is the true mean lies between 10.9 and 12.1. Okay, so that's how we can find the confidence interval. So this is the end of this long video on a confidence interval. Thank you so much for watching. If you find this video helpful, don't forget to give a like. Thank you so much.